So we're going to talk about the trigonometric leveling and a radial traverse. So basically what we did is we set up at benchmark southeast. So you can see down here in the corner, I'm at benchmark southeast. We do have data for the northern, easting, and z elevation of that benchmark. We backsighted the azimuth AZ, this point right here. And this is the data that we recorded in our field book. So we have a known northern and easting for the azimuth line. So when we set the total station up over the benchmark southeast and backside of the azimuth, we have a zero set line. So we started collecting data. Now technically we should have started with the PI and went around clockwise. But we went ahead and I'm going to go through it based on how it's laid out in the field exercise. So the first piece of data was we took a horizontal angle, a vertical angle, slope distance, horizontal distance, and vertical distance to the beginning point of our proposed roadway. Our proposed roadway is going to travel along this dashed line here, this green dashed line, and we're going to be putting in a horizontal curve later in the semester. So the first piece of data was the horizontal angle. So we basically took a horizontal angle to this point here. So we went from the zero set to the beginning point of our roadway. So we have a horizontal angle. We have a vertical angle. Now the vertical angle is when if we set up at a point here, so we've got a vertical angle of 92 degrees. If we set up at a point up here at the top of this triangle and we look down, zero being up here north or at the top of this line, and we look down, we're going from a 90 degree to 180, okay? So if the vertical angle, this angle here, is greater than 90 degrees, that means I'm looking downhill. So take a look at the next one. We're looking from the benchmark to PI. So we took a horizontal angle from here to here, from there to there, and then we took a vertical angle. But notice that the vertical angle is 89 degrees. That means we're actually sitting down lower and looking uphill. Okay, so if it was 90 degrees, it would be a horizontal, it would be a 90-degree angle if I was making it from this red line to this basically blue line here would be my 90 degree. So again, if I'm looking downhill, then my vertical angle is going to be greater than 90. If I'm looking uphill, if I'm standing here and I'm looking uphill, then the vertical angle is going to be less than 90. So now let's take a look at the other pieces of data that we've collected. We collected slope distance. The slope distance is this point here. It's the distance from where we're setting up our tripod to where our rod is. So slope distance is this, like it's going along the grade that you're looking. Whereas the horizontal distance is the distance if it was the straight across. And the vertical distance is the vertical change in elevations. So now notice that the vertical distance can be negative. That means I'm actually standing up at my point and looking downhill. So my vertical distance is negative. So in the second one at PI, if I'm sitting at benchmark southeast looking toward the PI point, then I'm actually looking uphill based on both the vertical angle and the horizontal distance. Okay, so that's why some of these values are positive and negative. So now that we've got the PI point, the next thing that we did is we collected the information from our backside angle to our end point. Okay, and then lastly, we recorded the data from our backside point to our southwest coordinate. Okay, that's just as a check to make sure all of our math is doing right. So in this, we knew that from the benchmark southeast here, the benchmark southeast, we actually looked downhill both to the southeast and to the beginning point, just based on our vertical angle and our vertical distance. We're also looking downhill at the EP point. and the PI point, we're actually looking slightly uphill. Our vertical angle is a positive, or is greater, I'm sorry, is less than 90 degrees, and our vertical distance is positive. Now what I want to do is explain how to do the calculations. When we do the calculations, what we're actually trying to figure out is x, y, z coordinates for the beginning point, the PI point, and the end point. So we're trying to find out our actual northing, easting, and z elevation.